Hey everybody, Trey here. Welcome back to another forecast discussion. We've got another severe weather threat for today. SPC has lofted a slight risk for parts of central Oklahoma, down through north and northeast Texas, through much of Louisiana and southern Mississippi. There's a tornado threat today with this system as well, kind of two separate areas of tornado threat. The first being from central Oklahoma, Oklahoma City area, down the I-44 and I-35 corridors, down into far north Texas, and then a separate area of potentially greater tornado threat down along the Louisiana and Mississippi Gulf coasts, places like Biloxi, Gulfport, westward to New Orleans, places like that. There will be a damaging wind threat as well for those same areas, and a large hail threat, particularly with the storms in southern Oklahoma and north Texas. SPC's put a 15% hatched area, highlighting the threat for possibly significant severe hail over 2 inches in diameter. And we'll take a look at why here in this video. So let's go ahead and get started. Let's take a look at our satellite image. As always, first, we've got a pretty big trough to highlight here. You'll notice the swirl in the flow here. This is our trough for today. It's a fairly high amplitude feature. You can see it's been able to dig all the way down into northern Mexico with quite a fetch of upper level moisture here in the exit region of the trough. It's going to be our main player for today. And then tomorrow there's a severe threat in the Midwest and Southeast. We'll focus on that in potentially a different video, but this trough is going to be our main player for today. It's going to move off to the east a little bit as the day progresses. Now, given the position of this trough, it's already kind of ejected into the southern plains, so we should have surface cyclogenesis that has already begun. And if we look at our surface map here, we'll start off with the broad view of the surface map. We absolutely do have our surface low out here. It's centered somewhere in far west Texas, southeast New Mexico, but pretty well-defined circulation here at the surface. Broad southeasterly flow here in the warm sector. Ahead of that, you've got your warm front kind of extending out this way, and some sort of cold front maybe down in here. Kind of hard to say, but we do have a pretty broad warm sector nonetheless associated with this surface low. Now let's take a look at our actual surface map here, our surface station plots. And we see we have our moisture that has already begun to advect or be transported to the north. You can see our 50s dew points reside pretty much up to the Dallas-Fort Worth metro area, and then areas south of that. And then our best dew points are 50s, our mid-50s plus, basically up toward maybe the Waco area and areas to the south and southeast, with the best dew points residing along the Texas Gulf Coast near Houston, Galveston, Corpus Christi. That's where our 60s reside at the moment. Not sure if those will make it all the way up to our target area for the main sort of diurnal or daytime mode with this system. But I do think it's plausible, given where the moisture is now, that we will see some mid-50s dew points bleed into southern Oklahoma and north Texas by this afternoon. And with that surface low moving off to the east or northeast as the evening progresses, the afternoon progresses, we should keep this southerly flow in place and allow that moisture to continue to advect northward into the target area, perhaps even into central Oklahoma by late this afternoon. Let's look now at our upper air charts here. 500 millibar flow. You can see where our trough is. Very well-defined trough here. The axis centered somewhere over central Colorado down into central New Mexico. Somewhat neutrally tilted, maybe a hair positively tilted, but our enhanced flow is kind of right around the base of that trough right now with the exit region. Beautiful defluence aloft. Again, the spreading out of the wind vectors is pretty well defined in this region from Oklahoma into Texas. And as we said in previous videos, when you have air that spreads apart aloft, well, the atmosphere wants to fill that void, so it brings air up from below, and you get lifting motion where that diffluence is best, which would be in the exit region of this trough. So lift, not an issue today at all. Let's see the 700 millibar flow. One thing before we move on with the 500s, though, is take a look at this cold air associated with this trough. Minus 24, these red dashed lines are the isotherms, or temperature contours. Minus 24, minus 22, minus 20 degrees Celsius in the core of this 500 millibar trough. That's very, very cold air aloft, and that's going to move over the region today. And given the position of that surface low, this is going to be another pretty classic cold core event. We've talked about cold core a lot this season, but it's when you have a very cold 500 millibar trough, generally a closed contour here. We'll take a look at the models to see if this might close off throughout the day. Regardless, very cold air associated with the center of this trough. Given the surface low, that's going to be just out ahead of it. Would expect that this is going to be a pretty solid cold core event. Of course, the John Davies work with cold core setups. Here's our schematic diagrams for cold core setups. You want to see that surface low and that 500 millibar closed low. Of course, we'll take a look to see if it's actually going to be a closed low, or if this will kind of be a pseudo cold core event without a true closed circulation at 500 millibars. But nonetheless, close proximity of the center of that 500 millibar trough and the surface low. You want to be right ahead of that surface low, right at the intersection of that kind of warm, the boundary between the kind of the dry line boundary and that kind of warm front, the northern edge of that destabilization. That moisture often feeds right into the low, and you want to be right at the nose of that moisture in that green circle to see the best chance for tornadoes. That's going to be the case today, and we've talked about this many times throughout the season so far. It's been the season of the cold core setups, and this is going to be no different. I think we're going to have to rely on that destabilization from the very cold air aloft to destabilize the atmosphere. And when you have really cold air aloft, that means large hail. So I would expect that there's going to be a large hail threat with the storms in Oklahoma and North Texas today. Let's go down to 850 millibars. We have a nice low-level jet in place, 45 knot plus low-level jet here across central Texas into much of the center and western part of Oklahoma. Out of the southwest. So it is out of the southwest, so that may actually pump a little bit of drier air associated with the kind of Chihuahuan desert out here. That may pump some dry air a little bit off the surface because it's oriented out of the southwest. If this were more of a southerly or southeasterly low-level jet, I would expect that to pump more of this moist air mass from the Gulf up north. But we'll have to monitor that, and we'll take a look at some soundings here in a second to see if we do have some dry air aloft. But that low-level jet should stay in place throughout the day given the continued kind of ejection of the 500 millibar trough. That low-level jet should stay in place. And yeah, let's take a look at some soundings now. Let's take a look at the Norman sounding. So this is the morning sounding from Norman, Oklahoma. And you'll notice fairly dry profile, as expected here. That low-level jet has pumped kind of drier air in these low to mid-levels here. The green profile, the dew point profile, of course, the red profile is the temperature profile. And fairly dry here in the kind of low levels. So this is not an ideal sounding you'd see on a chase day in southern Oklahoma and North Texas here. But we do have very steep lapse rates aloft already in place here, likely an EML elevated mixed layer that's advected out here from the desert southwest at the hands of that trough. So very steep lapse rates aloft already in place. Couple that with the cold air that's aloft that's going to be moving in, and we should have very, very steep lapse rates, very unstable mid to upper atmosphere today. So that should yield a large hail threat, potentially very large hail threat, 2 inches plus here for parts of North Texas and southern Oklahoma. Let's go down to Fort Worth here, see what kind of differences we have here in the soundings. So here's Fort Worth, a little bit more moist in the low levels, still somewhat dry air here in the mid levels. But again, steep lapse rates aloft there. Going to have a pretty stout inversion to overcome today, but I think once that destabilization from the cold air aloft moves in, that should rapidly erode and we should get storm development here probably between the I-44 and I-35 corridors of southern Oklahoma into North Texas by late this afternoon. Let's go down to the source region here, Corpus Christi, and you'll notice we have a somewhat of a fairly deep moist layer, if you can call this a pure moist layer here, up to about 800 millibars or so. Once again, we see those steep lapse rates in place, so pretty stout elevated mixed layer here. Already some elevated instability here, but again, a very stout cap to overcome, which I do think will erode pretty quickly once that cold air aloft comes in and that moisture continues to pump northward and destabilize the atmosphere. So all in all, some not quite classic soundings yet for the morning of a severe weather event, but I do think these profiles will improve throughout the day today. All right, let's take a look at the NAM here. This is the 12Z run, so hot off the press. Here's our trough centered across New Mexico and to central Colorado. Again, going to continue to move off to the east throughout the day. We should have that belt of enhanced flow moving around the base of that trough and ejecting kind of into the North Texas, southern Oklahoma area. Again, look at the beautiful defluence aloft here, the wind vectors spreading out. Excellent lifting mechanism here for the northern target here. Look at these temperatures aloft. Very cold air aloft associated with this trough. These grays represent anything greater than minus 20 degrees Celsius, which is very cold air aloft, and we see that start to impinge into North Texas, southern Oklahoma by mid-afternoon, 21Z, which would be 4 p.m. Central Daylight Time. So this cold air is going to continue to move off once that fully encroaches into the region by about 0Z. Between 21 and 0Z, we should see rapid destabilization and rapid thunderstorm development here, again with a large hail threat given the cold air aloft. Low-level jet hangs around throughout much of the day, moves off to the east, just ahead of that low-level circulation there. So we have the highest low-level jet across North Texas here, bleeding into southern Oklahoma. Would expect that to elongate and enlarge the curvature in the low-level photographs for a potential tornado threat with these storms. We'll take a look at that in a second. I do think the moisture may be a limiting factor, especially if surface temperatures evolve and reach into the low to mid 70s. The temperature dew point spreads may be a little bit higher, which heighten the bases of the thunderstorms and promote more of an outflow dominant storm mode than a tornado threat. But still, I think we're going to be within the range that tornadoes are going to be a possibility today for southern Oklahoma into North Texas. So here's your surface pattern. You can see that well-defined surface low moves off to the northeast, located basically over Wichita Falls, Vernon area of northwest Texas here by 21Z, 4 p.m., with a pretty broad warm sector ahead of that. NAM showing quite cool temperatures out ahead of that surface low, and I think this is once again a victim of the cold bias in the NAM. The NAM usually is always too cold with the surface temperatures here, and you can see 64 at Dallas, 68 Ardmore. So very cool temperatures here aloft, at the surface. I don't think we will be that cool. If we take a look at the visible satellite here, let me zoom in if I can to the southern sector here. You'll notice we have fairly clear skies already in this region, and that's going to promote a lot of solar insolation throughout the day, a lot of surface heating. I think we get at least into the low 70s at a minimum here. You can see temperatures already up to 60 in southern Oklahoma. This is the Oklahoma mesonet. Temperatures already up to 60 here in southern Oklahoma. So I think we'll get probably up into the low 70s at a minimum for today, given that degree of surface heating. So I think the NAM is going to be a little bit too cool with the surface temperatures here. And if we do warm into the low to mid 70s, I think that will provide more destabilization for the atmosphere. So we'll have to keep that in mind when we look at some of the forecast soundings here. Let's look at the moisture, how the moisture advects into the region. This is at starting at 12Z. You can see those mid 50s dew points here, kind of relegated far to the south, across East Texas. And if we match that up, 15Z, it's going to be 10 a.m., so not quite 10 a.m. when we're doing this video. But here's our current surface map, and we've got some mid-50s all the way up kind of right to the south of that boundary there. We got a 57 here to the south of DFW. Not sure if that is accurate or not, but for the most part, the mid-50s confined down to the south here. So that may be a little bit farther north than what the NAM is showing here. So moisture may be a little bit ahead of schedule, at least according to the NAM. But nonetheless, this is by 21Z, 4 p.m. We see those low 50s dew points streaming into southern Oklahoma. Again, I think it is plausible that we might get 54 or 55 degree dew points into southern Oklahoma. Better dew points with southern extent into North Texas, with the 60s all the way up almost to the Dallas-Fort Worth metro area there by 4 p.m. But our main zone of initiation is going to be right along this dry line, right ahead of the surface low here, where that moisture kind of tucks into the surface low. I think the storms are going to initiate somewhere in that region right there. So places like Lawton, Fort Sill, maybe down toward Ringling, Oklahoma, then into parts of North Texas, northwest of the Dallas-Fort Worth metro area. I think we'll have the best chance to see initiation probably by about 4 p.m. or so, 3 to 4 p.m. or so. Then we get really rapid destabilization. You can really see that moisture wrap into that surface low. It's going to be located right in there. Look at that tongue of moisture wrapping into the surface low. Very, very classic cold core type setup. By this time, we'll have that cold air aloft spreading over this moistening warm sector here. So by this point, we should have perhaps an arc of supercells along this kind of moisture tongue here, focusing with the best tornado potential probably along right at the nose of this best moisture, right where it kind of feeds into that low. I think that'll be the best chance for tornadic supercells here. But again, large hail going to be the main threat today, perhaps damaging winds as well, maybe a tornado or two. Would not be surprised to see the SPC go with an upgrade in tornado probabilities here with the upcoming outlook. Let's take a sounding here from right at the nose of this moisture tongue, then we'll take one down into North Texas, just northwest of the Dallas-Fort Worth metro area. So this is going to be our southern Oklahoma target. Once again, showing 62 degrees here at the surface. I'm just not convinced that it's going to be that cool. Because it's 62, the NAM is showing this pretty stout inversion right here, which I hesitate to believe just because of the NAM's tendency to always be way too cool with these surface temperatures. So if we can get into the low to mid 70s, the profile will be out in here, and we will probably have something that looks more like this, perhaps greater instability, and that inversion will not really be there all that much. So something to keep in mind, but look at that hodograph, very favorable hodograph for perhaps tornadic supercells here. Large curvature in the low levels, approaching 300 meters square per second squared effective helicity. So very large looping hodographs here in southern Oklahoma. This is North Texas, much of the same. Again, I think a little bit too cool. But places like Gainesville, Sanger, areas to the west, going to be under the gun for perhaps a tornadic supercell or two come late this afternoon, early evening. So Gainesville, Sanger, Nocona, Bowie, Decatur even. Perhaps even as far west initially as Wichita Falls. We'll have to see where that moisture tongue sets up, but I think initiation will be somewhere along that kind of Duncan, Oklahoma to Ringling, down toward Nocona, Texas, and then eventually moving off toward the I-35 corridor. Perhaps even as far north as Norman, down south through Sulphur, Ardmore, Windstar, Gainesville, Texas, Sanger, Texas, places like that by this evening. As far as now east and northeast Texas go, we finally destabilize out in that region. We get those 60s dew points in there by late this evening into the early morning hours. Do think we will have the chance for additional storm development out here in northeast Texas, with perhaps a damaging wind and hail threat. Places like Paris, Texarkana, and places to the south, Mount Pleasant, Sulphur Springs, down toward the I-30 and I-20 corridors. Tyler, Longview, places like that will have the threat for severe storms overnight. Tornado threat with these should be minimal. There should be some surface cooling that does take place after dark. Should be quite an inversion that builds in. Well, that's interesting with the 60s dew points in there. Not much of an inversion. Given large looping hodographs, maybe a tornado or two out here after dark, but SPC does not highlight that area for potential tonight. But I do think northeast Texas will see a threat for severe storms with large hail, damaging winds, and maybe a tornado or two come late this evening after dark into the overnight hours. Let's take a look at the wrap real quickly just to kind of see. I want to take a look at the surface pattern here, most of all here on the wrap, just to see how it evolves compared to the NAM. And you can see right here, the wrap has much, much warmer surface temperatures, even getting southern Oklahoma into the almost 80s, 84 here at Wichita Falls, 79 there for Lawton, 74 for Ardmore. I think that's going to be more like it. But this is what I'm talking about. The NAM is always too cool with the surface temperatures. I think the wrap has a much better handle on the surface temperatures here. And let's see how our moisture does. And you can see by 14Z, it would be 9 a.m., does have some of those mid-50s dew points up into east central Texas. I think the wrap has a much better handle on the surface pattern here at this point. And it does get those low 50s dew points up into southern Oklahoma. By late afternoon, those upper 50s into North Texas. If we go to 23Z here, let's take a sounding. We'll take one from North Texas as well, just northwest of DFW. So this is the wrap sounding. Those higher surface temperatures are going to result in higher temperature dew point spreads, more high-based storms, but perhaps more outflow dominant storms. But in a cold core setup like this, you can never put it past these to produce tornadoes. Still decent instability here. Steep lapse rates aloft, well over 8 degrees Celsius per kilometer throughout the layer, with some turning in the low levels. Not quite as much as what the NAM was showing, but with rapid destabilization, perhaps more destabilization near the surface. That may not matter as much. This is North Texas, not quite as favorable there of a hodograph. Let's move on to 0Z. Let's go on to 1Z, see if we get a little bit better moisture advection into southern Oklahoma, North Texas here. And we should, with time, we should get a much better destabilization given moisture advection near the surface. We do see that. A little bit of cooling, a little bit of an inversion there. That I think will be pretty easy to overcome, but again, steep lapse rates aloft here with an increase in the hodograph here. So I think the main threat today is going to be perhaps an arc of supercells firing on that surface low, right somewhere up in here, surface low right in there. Whoops. And right on that arc where that moisture feeds in, I think we'll get an arc of supercells. Just starting west of the I-35 corridor, perhaps areas like Lawton, Fort Sill, down toward Ringling, Oklahoma, and east of Wichita Falls. Then that will approach the I-35 corridor from Oklahoma City to North Texas, Gainesville, Sanger, perhaps as far south as Denton here by early evening. I think the main threat is going to be large hail, given the very steep lapse rates and cold air aloft. But I do think the threat for a tornado or two is there. These cold core setups are often perform with the tornado potential. So would not be surprised to see the SPC up the tornado potential to a 5% here in the 11:30 outlook. But we'll see. So let's take a look finally at some cams here, some convective allowing models. Just for kicks, this is the 12Z HER. Actually, let me move up here a little bit. Let's go to 13Z. Give you the most recent look at this. So you can see here by about 22 to 23Z, we have initiation here. Southern Oklahoma right on that arc. Should be an arc of supercells here. By 0Z, that arc moves off to the west, does extend as far north as the Oklahoma City metro area, but moving toward the I-35 corridor. Places like Ardmore, Windstar down into North Texas, places like Gainesville, Sanger. And then with time, it does kind of congeal into a line here on the HRRR. Not sure if that is going to be the case or not. I don't expect the storm mode to be super messy here. There is quite a bit of forcing, and if we look at our shear vector orientation compared to the boundary, the initiating boundary, we do have a good degree of perpendicularity among the wind vectors here. Our shear vectors are quite perpendicular to the initiating boundary, that kind of dry line there. So would expect there to be a decent window for discrete storm development later this afternoon, and probably eventually it will congeal into a line. Let me go back to the 12Z here just to give you a picture for that northeast Texas, East Texas region. Kind of get these warm advection showers throughout the day that do eventually morph into perhaps severe storms here overnight, places like Texarkana, far northeast Texas, and then our main area with a hail and more of a damaging wind threat with time here as it moves off into eastern Oklahoma. I think that's a decent depiction of it. Let's take a look at the WRF ARW here. It's just coming in as we speak. Once again, initiation about 22-23Z, and right along that surface low, perhaps a little bit more of a semi-discrete mode here into southern Oklahoma, far north Texas. Kind of the same thing as what the HER was showing. And then finally, we'll take a look at the NSSL WRF and see what it shows. Much of the same kind of initiation here, a little bit farther west. Not sure if that's going to be the case. We'll have to watch the observations throughout the day and see where that moisture tongue sets up and where that surface low is. So I think initiation by about 4 to 5 p.m. here across southwest Oklahoma, northwest Texas. Then storms will move off toward the I-35 corridor by late this evening with a separate area of kind of warm advection, perhaps strong to severe storms out here into northeast Texas, places like Texarkana, areas to the southwest there. So that's all I've got for now. Again, we've got a slight risk, level 2 out of 5 for central Oklahoma down into north Texas. Not really going to focus on this tornado threat down here in Louisiana. Going to kind of be warm advection stuff down there along the Gulf Coast. But I wouldn't be surprised to see them up this to a 5% tornado probability later on. Again, places like Oklahoma City, Norman, perhaps even more so down toward Lawton, Fort Sill, Duncan, Ringling, Oklahoma, Ardmore, Springer, Windstar, and then bleeding into North Texas, places like Gainesville, Bowie, Decatur, Sanger, places like that. Dallas-Fort Worth metro area, not going to be dealing with much of a storm threat, I think, today. I think the activity will be to the north, particularly the tornado activity, going to be to the north of Dallas-Fort Worth, and the large hail activity as well. But does include the Oklahoma City metro area, so in this hatched area, particularly going to need to watch for significant severe hail. So that's all I've got for now. Thanks for watching, and we will see you in the next video.